Okay, question number 2. A particle moves in an orbit with an acceleration. So this is the acceleration. I've been given the acceleration. So A of t equals 2 cos of t in the I plus sine of t in the j. And I know that that's okay. The initial velocity is negative I in negative j, and the initial position is 2I. Okay, find the equation of the particle's path. Okay, so V of t will equal the integral of A of t, which is the integral of 2 cos of t in the I plus sine of t in the j, which is going to be the integral of cos is sine. So 2 sine of t in the I minus cos of t in the j plus some constant c. And I know that it initially, so the velocity is -1. So negative j equals 0 in the I minus 1j plus c. Therefore, c equals 0, which gives me a v of t, which equals 2 sine of t in the I minus cos of t in the j. So that's going to be my velocity expression. And my position will be the integral of 2 sine of t in the I minus cos of t in the j dt, which will be -2 cos of t in the I minus sine of t in the j plus some d. And I'm told that the initial is 2 in the I. So 2I equals cos of 0 is 1 minus 2I minus nothing in the j plus d. D equals 4 in the I, which gives you a position vector equal to 2 sine of t in the I plus 4 minus sine of t in the j. Now that's got to be this line here, not that line there. So let's get rid of that. And I need to put in this. So minus 2 cos of t in the I. So that's going to be that expression. Okay, so I need to find the Cartesian equation of that. So x equals -2 cos of t, x squared equals 4 cos squared of t, y equals 4 minus sine of t. No, it doesn't, because this 4 is to do with I, so that's 4 is there, and there's no 4 there. It's going to be 4 there, which means I've got x minus 4 on -2 equals the cos of t, which means that x minus 4 squared on 4 equals the cos squared of t, and y squared equals the sine squared of t, and since sine squared of t plus cos squared of t equals 1, therefore x minus 4 squared on 4 plus y squared equals 1, and that is the Cartesian equation of the path. So that's part A. In part B, we need to find the maximum and minimum speeds. So we're looking for the magnitude of the velocity of, so that's going to be the square root of the I component of the velocity squared plus the j component of the velocity squared. And my velocity is this one here, so 2 sine and cos. 2 sine of t cos of t. So it's going to be the square root of 4 sine squared t plus cos squared t. And I'm looking for the maximum and minimum and when they occur. So let's see what we can get here. The square root of, I'll open up a bracket and I'll put 2 sine of, not 2 sines. Start again. 2 sine of x. And I'll put that in a bracket. And I'll square that bracket. Try and square that bracket. Plus, might put my bracket in first, and then I'll square the bracket and go back inside the bracket and put cos. Simplify, I could write that. Okay, so let's have a little look. Drag and drop. I could go zoom auto. I'm seeing that I have a max of 2 and I have a minimum of 1. So max speed 2, minimum speed 1. So if I go interactive calculation, f min about x, and I might go from 0 to 4 pi, and I'll see what values I get to find out with what happens to the patterns. So it's equal to 1, and that's at 0, pi, 2 pi, 3 pi, 4 pi. So at t equals 0, pi, 2 pi, 3 pi, therefore t equals n pi, where n is an element of z. So that's the minimum. To look at the maximum, I might just go back up there and bring up the keyboard, go to ABC and put in max, and then press X to get rid of that Z. And that's 2, and at pi on 2, 3 pi on 2, 5 pi on 2. So that's t equals pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2. So by putting in 4 pi, I got enough of the answers to give me a pattern. So that's all the odd pi's on 2. So t equals 2n plus 1 on 2 pi, where n is an element of all real of z, which are integers. So that's the maximum and minimum speeds. So I've got to find when the acceleration and the velocity are at right angles. So therefore I want the acceleration of t dot the velocity of t to equal 0 and find the t values. Okay, so the acceleration, well, that's my velocity, 2 sine t minus cos of t. And the acceleration is up the top. There it is there, 2 cos of t sine of t. And the dot product is, I'm going to multiply the i's and the j's. So 2 cos of t times 2 sine of t is 4 sine t cos of t plus sine of t times negative cos of t minus sine t cos t equals 0. I've got like terms, so 3 sine of t cos of t equals 0. Using the null factor law, that's going to happen when sine of t equals 0, and that will be when t equals 0, pi, 2 pi, 3 pi, etc. Or when the cos of t equals 0, that's going to happen here and here and here and here. So t equals pi on 2, 3 pi on 2, 5 pi on 2, etc. Combining these together, I get 0, pi on 2, pi, 3 pi on 2, 2 pi I could write as 4 pi on 2, then 5 pi on 2, 3 pi is 6 pi on 2. I think that I have t equals all of the n pi on 2s, where n is an element of all integers, and that will be my answer.